Our last example today is a calculator question. Okay, solve cos x equals x squared over the set of all real numbers and give your answers to the nearest hundredth. Usually the give your answers to the nearest hundredth is the indication that it would be a calculator kind of question. This is a kind of question where I'm going to show you how we're going to solve it using our graphing calculator, but you will never be asked this kind of question on your exam. But the skills and the ability to use technology and to understand what's going on is important. So what this means is we want to solve cos x equals x squared. And we have no algebra skills up till now that would allow us to do this. But if we think about this graphically, and we're going to draw a sketch without our calculator, we know the graph of cos. You could graph cos by going up to 1, down to -1, marked a period of 2 pi, divided into 4 equal sections. A cos graph starts at a maximum, then middle line, minimum, middle line. And would continue on forever like that. I'm going to put a green line under the left side because that's graphing cos. I'm going to put a purple line under x squared because you know how to graph x squared as well. It goes through 0, 0. It goes through 1, 1. Okay, this is where things are going to get tricky. Where do I put the dot for 1, 1? Somewhere at 1 for the y, that's the easy part. Where on the x-axis would 1, 1? What's my best bet? Here, 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 here. That's too many dots. I'll just take those away. Here and here, here and here. Where would they be? Just before pi over 2. Why? Because pi over 2 is about 1.5. Half of 3.14, 1.57. So this dot for 1, 1, this is at 1.5. I guess that would be 1, 1. And so now I can go and draw my parabola up like this. So that's my graph of x squared. If I want to know where they're equal, I'm looking for this point and that point. Now, your graphing calculator way to solve this would be to go to your calculator in equation 1. In equation 1, type cos, still on the yellow pen. Type cos of x. In equation 2, type x squared. Now, when you hit graph, you're going to have whatever window you had from before. This is the window that I had from before. And that's enough to solve it. But if you wanted your window to match up with this window, a couple of things you can do. On your zoom button, one of the things that's sometimes nice whenever you're doing something with trigonometry is number 7. So if you go zoom and then number 7 to trig, what zoom 7 does is it automatically goes from 0 to 2 pi, from -2 pi to 2 pi, maybe a little bit more, and then goes from -4 to 4. That pretty much matches up with my screen nicely. So I didn't have to go to my window and set it up on my own. So zoom trig is a nice option. Now, if I want to find out where those two graphs intersect, second, calculate. I want to find number 5, the intersect. Enter on the first curve, enter on the second curve, guess, and it'll always find the nearest one. And it tells us x is equal to 0.824. I can use symmetry to find out that the other one would have to be the same because of what I know about parabolas and what I know about cosine graphs. I could also find that second one by going to my calculator and doing second, calculate, intersect again, and just moving my cursor closer to the second one, pushing enter on the first curve, enter on the second curve, enter when it says guess. And sure enough, it's negative 0.824. In this case, we don't care about the y value because we were solving. There is, in fact, no y values whatsoever when we start. But our technique of graphing them both separately then allows us to find out where they intersect to find out what the solution would be. Yes, you could also write it as plus or minus. To the nearest hundredth, thank you. Again, one of the things that often happens, and this is a great example of it, my rounding not to the nearest hundredth, you get involved in a question. You start solving it, you get onto a technique, you're going, things are going well, and you're like, you get your answer and you feel good and you just want to keep going and on to the next question. One of the skills that will help you not make an error in rounding like I did or an error in your solution is once you're done a question, you should always go back and reread it again. Did I miss any details? Was there a part B to this? Did they want the domain or the range or something else in addition to what I just solved for? So a good strategy on a quiz or a test, just to make sure you're not missing any of those things, is once you're done, to look back at it again. And this is true for like so many things in life. If you're writing someone a message before you hit send, it's not a bad thing to read it over again, right? One wrong word in there could make it mean a totally different thing, and then you've got 2 days of trying to settle down social media because of what you accidentally said. Okay, questions for practice on this one is just number 7.